Hello and welcome to another 2021 MEF 3.0 Proof of Concept Showcase, where MEF members collaborate to demonstrate MEF 3.0 based use cases that validate, evolve, and inspire the work of MEF. I'm Kevin Vachon, your host, and today we're showcasing POC 136, Application Optimized SD-WAN with Cisco, Equinix, and Engena. SD-WAN applications, Kubernetes clusters. I'm quite keen to see how all of these items come together to form a comprehensive end-to-end solution. Comprehensive end-to-end solution has been a hallmark of all of our POCs to date. They've been very impressive. Our program today kicks off with an introduction to the POC by Fabio Mino, a distinguished engineer at Cisco. He'll be followed by the demonstration itself and a business panel led by Marcus Hackey, Managing Director of Engena. Then there'll be a Q&A session where we'll direct your questions to representatives of the participating companies. You can queue up your questions at any time by selecting the Q&A tab on the right. So let's get started and we'll hear from Mino.
Hi there. Thanks for joining us today. I'm Fabio Mino, a distinguished engineer at Cisco. Together with my colleagues from Engena, Equinix, and Cisco, I welcome you to the Application Aware SD-WAN demo for the MEF 3.0 POC showcase. In this POC, we will be exploring the boundaries between application and networking, leveraging the intersection of two important trends that we have seen emerging in the last few years, SD-WAN and cloud-native applications. From one hand, the software-defined wide area networking trend is providing an unprecedented user-directed and application-directed control over network resources and WAN service capabilities. On the other hand, in the application world, the rise of cloud-native applications has provided great flexibility and robustness in hosting applications at scale in both public and private clouds. With the application and users widely distributed in branches, home offices, clouds, and data centers, modern SD-WAN solutions provide an effective toolbox to improve the application-to-application and application-to-user experience. However, while Kubernetes and SD-WAN are often deployed together, they tend to be unaware of each other. The NetOps teams would typically focus on WAN optimization, while the DevOps teams are focusing on application development and deployment. There are many deployments today where the application infrastructure uses the network as a pure transport without leveraging its full potential. In some other deployments, the underlying network optimization falls short due to the lack of visibility of application requirements. A lot of toil and back and forth is required for the DevOps and NetOps teams to coordinate and provide per application WAN optimization. The Cloud Native SD-WAN project is a set of open source components that bridge SD-WAN solutions with Kubernetes. It was created exactly to address these challenges. Cloud Native SD-WAN, CN1 for short, recognizes the critical role that appropriate network operations play in delivering optimal application experience, and that infrastructure and service providers are crucial to ensure that the network is optimized for every single application. The project also recognizes that for the DevOps teams, making the most out of the network capabilities is not straightforward, as they don't have visibility of the possible network optimizations that are available. Similarly, for the NetOps teams, it's often very hard to fully understand the requirements of the application. CN1 defines a clear interface between DevOps and NetOps, between Kubernetes and SD-WAN. The service providers NetOps team that are aware of the specific characteristics of the underlying infrastructure and network deployed use CN1 to expose mappings between application metadata and network policies. In this way, they abstract the complexity of fine-tuning the network and just expose to the DevOps a set of simple and easy-to-use application attributes. The DevOps can then use these attributes in the form of simple annotations while they are deploying their applications. As a result, TN1 effectively makes the SD-WAN NetOps optimization services easy to be consumed by the DevOps, automating the delivery of optimal application experience as soon as new cloud-native application is deployed. This POC brings together Cisco SD-WAN, Engina managed services, and Equinix Cloud on-ramps to create a new model for a cloud-native SD-WAN that supports the needs of Kubernetes applications, offering automated SD-WAN optimizations per each Kubernetes application deployed by their customers. This results in an easy-to-consume model of SD-WAN services, where customers just express their application networking needs with simple Kubernetes configurations, and the managed SD-WAN solution automatically and transparently renders the appropriate network optimization. Let's look now at a cloud-native SD-WAN in action, as my colleagues from Engina, Equinix, and Cisco will guide you through the application-aware SD-WAN technical demo.
Welcome everyone to the technical demo for the MEF 3.0 POC application optimized SD-WAN. I'm Alberto Rodriguez Natal from Cisco, and I'm here with my colleagues Andre from Engina and Johnny from Equinix. And in this demo today, you're going to see in action the Cloud Native SD-WAN, the open source project that brings together Kubernetes and SD-WAN, and that allows to map DevOps application metadata with NetOps SD-WAN policies. To showcase this integration, we have built a demo where a user in a branch tries to watch a video streaming from a Kubernetes application running in the cloud. The branch to cloud connectivity is enabled by Cisco Power Engina's managed SD-WAN service connected to Equinix Cloud Exchange. Before we jump into the demo itself, let's spend a few minutes to understand the different solutions and technologies that we are using on this POC. And for that, we'll start with Johnny, that will provide an overview of the Equinix components.
Thank you, Alberto. My name is Johnny Achelodi from Equinix. Network Edge is a Equinix product launched in around June 2019, and it is a virtual marketplace deployed as a service on platform Equinix. Equinix Network Edge brings in many benefits. Let's say it's a speed of provisioning of the network services. We can deploy the network services such as router, firewall, SD-WAN in minutes. It also offers the virtual servers up to 16 cores and throughput up to 10 gigabits per second. It also has the lower capex, essentially because no hardware is required. It also offers the zero-touch provisioning with APIs. Equinix Network Edge also offers the flexibility in billing without any long-term contract. Network is also have a different kind of virtual network functions offered by the multiple vendors, right? Also, you have a choice of the multiple metros. Network Edge is available in 11 metros as of today and targeted to extend it up to 25 metros by end of 2021. Network Edge has also choice of 150 odd public and private cloud service providers connectivity using Equinix Fabric. As a part of this demo, we have provisioned CSR 1000V SD-WAN VNF in Network Edge. And this VNF is L2 stitched to the Google Cloud Platform over Equinix Fabric. Also, it is connected to Engina Hub using the BYOC method. With that, I'm handing over to my colleague, Andrej at Engina.
Thank you, Johnny. My name is Andre Vereb. I'm working for Engina. Engina delivers the SD-WAN as a service with the global end-to-end platform powered by Cisco, providing fully automated, highly flexible connectivity services to any location in the world. This is possible due to our globally deployed hubs, backbone, as well as our alliance partner local networks. The platform simplifies the connection between NetOps and DevOps, delivering a fully orchestrated and automated SD-WAN that is integrated into the C and WAN environment via API. The result is a simple and powerful networking as a service that can scale to meet the DevOps demands. NetOps can easily configure and deploy through our portal all aspects of networking infrastructure. All it takes is to pick a service from our global service catalog, enhance it about the customer-specific information, and deploy. Our pre-designed access designs with a single or redundant CPE supports between 1 up to 4 from a private as well as a public internet access underline lines. Because of the API integration, DevOps can easily optimize the network for the application-specific needs. NGENA's platform supports both public and private underlay connection, ensuring the best quality of service for applications and optimized traffic flows. For this particular demo, we are using IPL Tunnel 0 Bronze and EPL Tunnel 1 Gold. Equinix helps bring NGENA private and public underlays to the cloud with the seamless connectivity. And with that, I'm passing over to you, Albert.
Thank you, Andre. Thanks a lot. So Cisco is bringing two components to this POC. On one hand, the Cisco SD-WAN solution that I've mentioned powers the NGENA managed SD-WAN service. And on this slide, you can see some of the Cisco SD-WAN components, like Cisco vManage on the top and a few Cisco SD-WAN edges at the bottom. Now, Cisco SD-WAN brings a series of benefits, and some of which are particularly relevant for this demo. So I would like to highlight those. First of all, Cisco SD-WAN helps us here to build a secure overlay that connects to the cloud. And this is done simply in a very automated way. Second, Cisco SD-WAN provides application awareness that then allows us to have a very fine-grained policies, really specific to each application. And you'll see that in action in a second in the demo. Third, for this demo, we are really leveraging the extensibility and programmability of the Cisco SD-WAN solution and using it to connect with an external framework such. So if you consider all this together, what you can see on this demo is how we are really using Cisco SD-WAN to consume application metadata from the cloud and use it to drive network optimizations. The second major aspect that Cisco brings into this POC is the Cloud Native SD-WAN open source technology. As we discussed during the business intro, CN1 is a project very aligned with the Kubernetes ecosystem that performs network integration the cloud native way. On this slide, you can see on the right some of the CN1 open source pieces. And you can see that some of the parts of CN1 run directly inside Kubernetes, very close to the application. That allows CN1 to extract application information, including things like any network metadata that the DevOps have added, and then store this information into an external service registry. From there, the rest of the CN1 components can retrieve this information, render it into SD-WAN policies, and push them to the Cisco SD-WAN. Here it's important to notice something, and is that the actual mapping of application metadata to SD-WAN policies is configured by the NetOps, since those are the ones that know best how the network runs and how it should run. So those are the ones that decide how the annotations on the applications are going to look like as SD-WAN policies. For instance, in this demo, we use that capability to say we take the NetOps role and we determine that the traffic for applications that are labeled as video by the DevOps should go into the gold tunnel over the SD-WAN, because we know that tunnel has better bandwidth and lower latency, and that's what we want to apply to those particular applications. So with that context, I think we are ready to jump into the actual demo. For this demo, I'm going to play the role of a DevOps person at an enterprise that has deployed a video streaming application in a Kubernetes cluster in Google Cloud. I want to make sure that the application experience is as good as possible for users watching the video from our branch offices, so I'm going to do a quick check. First, I make sure that the application is running in Kubernetes, and I take note of the IP address and port that a user will need to connect to this application. With that information, I should be able to come to a machine on one of our branch offices and start the streaming from there, just as a user would do, and see how the video looks like for them. Okay, right now I can see the video coming through, but the experience is not really good. I can see that the video stops sometimes and I can see some artifacts. If I take a look at the network performance on the machine, I can see that it doesn't really go above 3 megabits per second. Considering that this is going over a WAN connection, I suspect that there may be some network issue here. Normally, I would call the NetOps team to explore with them how to improve the application performance. However, I remember that they told me that they have this new CN1 system in place, and that I should be able to use it to automatically optimize the network for my application. It seems that I just need to annotate them properly, so I'm going to give that a try. I'm going to come back to my terminal, and I'm going to edit the application specification to add this annotation. In particular, I'm going to add the annotation traffic profile equals video. And that's because this is a video streaming application. I save the changes, and hopefully this will help with the networking issues that we saw before. If after a moment we come back to the machine on the branch, we can see that things are starting to look much better. First, the bandwidth consumed seems more aligned with what I would expect for my video application. And I can also see that the video now is smoother than before, and that all the artifacts are gone. Now, as a DevOps, I'm really happy right now with application performance. But to explain what has happened here, I need to switch roles for a second and become a NetOps. The explanation is that, as a NetOps, I have configured via CN1 a policy that would put the traffic annotated as video into the SD-WAN tunnel labeled as Tunnel 1 Gold that we saw in the previous slides. That is the tunnel that would provide the best application experience for video applications, and that's the one I want to use when a DevOps selects the traffic profile video on the Kubernetes cluster. Still, as a NetOps, we can come to be managed to get further insights on the differences between the two tunnels. We already saw that the gold tunnel has better bandwidth than the bronze one, but here we can see that it also has fewer drops. If we take a look at the latency and jitter, we can see that over time the gold tunnel tends to have better latency and jitter than the bronze one. So all these network characteristics are things that we consider as NetOps while building policies. And now, thanks to CN1, we can offer the NetOps expertise in an automated way to the DevOps applications. And that concludes this technical demo session where we have demonstrated the advantages of Cloud Native SD-WAN and the Kubernetes SD-WAN integration. In particular, we have seen how CN1 makes SD-WAN services easy to be consumed by applications hosted in Kubernetes, and how it can automate the optimization of application experience by streamlining the DevOps and NetOps coordination. In conclusion, CN1 helps to simplify the implementation of cloud-native services and significantly enhances customer experience.
Thank you to all who are tuning in and joining us for the virtual POC. And thanks to the MEF for the opportunity to our teams to showcase Cloud Native SD-WAN. I'm Markus Hacker, founder and managing director of NGENA. I'm looking especially into product management, platform architecture and operations of the Jena platform. As you have seen in the technical demo, there's an exciting new model provided by the cloud and software-defined networking that really bridges the historical driven divide between DevOps and NetOps. With new tools and platforms like APIs, abstracted network fabrics, and highly scalable service delivery routes, and cloud on-ramps, the WAN has more flexibility than ever before to meet the needs of applications. It's my pleasure to be joined today by Steve Wood from Cisco and Tom Jin from Equinix in this discussion about this new so-called Cloud Native SD Wide Area Networking, or CN-WAN, highlights what the future holds for NetOps and DevOps in this world of Kubernetes and hybrid cloud environments. Steve.
Oh, thank you, Marcus. It's great to be here to talk about some of these great innovations around application layer integration with the network, and I hope you all will enjoy the discussion and the POC. Hello to everybody. My name is Steve Wood. I'm a principal engineer at Cisco in the intent-based networking group, and I've been at Cisco for over 20 years as a product and network architect. I was the solution architect for Cisco's IWAN solution, as well as our latest Cisco SD-WAN. And I'm currently focused on developing Cisco's next generation SD-WAN network offerings for cloud and application layer integration. Tom, would you like to introduce yourself?
Thanks, Steve, and thanks, Marcus, and thanks to MEF for allowing us to present our point of view here in terms of, and proof of concept in terms of what we're actually doing. My name is Tom Yen from Equinix. I lead the business development activity in the networking space. I've been at Equinix for 3.5 years and helped launch Equinix new product offering called Network Edge. It is a virtualized network function as a service that offers various different market-leading networking companies like Cisco virtual instance to be made available in minutes. So I'm excited really to be able to talk to you all, and Marcus and Steve here, and hopefully you guys will gain something out of it. Thank you.
Thanks, Steve and Tom. So looking into the market, business success very much depends on the speed of implementation and flexibility to adjust for customer requirements. Automation can not only significantly increase speed compared to manual implementations, but also improve quality of service delivery as it is tested upfront and delivers always reproducible results, avoiding any kind of manual errors. To implement automation across different systems and technology domains, APIs play a crucial role. Steve, how does Cloud Native SD-WANs benefit the application designers and application quality, and what is the importance of APIs?
Yes, well, Marcus, that's a great question. I mean, driving application quality of experience and intent-based networking is sort of at the forefront of SD-WAN for sure, and it has been in the past and is more so in the future. At Cisco, we really see a tighter integration between application layer and session layer and the network as a key element in the overall evolution of SD-WAN. So CN SD-WAN is one of a number of innovations in this area that we're focused on, with the goal of changing the consumption model of the network, making it much more automated and adaptive to the needs of the application layer provisioners and the applications themselves. So we see a move away from the sort of match and set type network policies of the past to more intent-driven declarative policies. And so CN SD-WAN, or Cloud Native SD-WAN, is a great example of innovation in this area. The application provisioner spends less time programming the network and more time focused on application deployment, while at the same time being able to use the power of the network to provide service differentiation so that they can ensure that their applications are getting good performance and having good quality experience for the users, right? So what we want to enable here is to give the application designer a service differentiated view for consuming network services. For example, low latency services, bulk services, transaction services, for if you can imagine, but we expose that capability at the application layer via APIs and annotations that tag the services so that application flows can get the treatment that the network designer intended for proper quality of experience, and that's key, right? So this doesn't have to be, by the way, just performance. Today, that's an example we're giving, but in the future, we can imagine that this could also be security preference, where I want the traffic to flow, and network preference, or other policies that can be coded at the application layer under the control of the DevOps team, but allow the application layer to consume the network services in a differentiated way.
So further to what Steve says, from an Equinix viewpoint, we view CN SD-WAN API capability is also allowing the management of that experience, right? So it allows for network traffic flows across both public and private connectivity. It allows for securing of the endpoints, identity of devices, users, and application to be aligned and given access control for each of the transaction flows at the fingertip of the DevOps team. This capability enables NetOps and DevOps also to allow to focus together rather than against each other to actually meet the need of business, enabling rapid deployment of new applications, as well as prevent and mitigate any potential attacks quickly and appropriately. So minimizing the impact and then being able to resolve the business needs. So we see that as really, I think, critical in ensuring that the business get the true full experience that it should enjoy out of actually being able to program a network. Marcus?
Absolutely. Yeah, absolutely. I really believe this makes the value of APIs very clear, Tom and Steve. But now, how does the API-driven model achieve this benefits you have been talking about really? Steve, what's your view?
Yeah, great question. So, the Cloud Native SD-WAN approach really tries to, provide this intent-based abstraction between the application layer and the network layer. So we want to give the freedom for both teams to work independently. So APIs, of course, can enable the use of structured data model exchange to describe an agreed set of policy behaviors, right? And that can be communicated in a standard way between management systems from different providers, cloud providers in this case, right, to the Cisco SD-WAN management controller. And once you have that capability, the NetOps team then has the freedom to basically expose services that the application layer can consume via these structured tags that can be communicated over the APIs, right? That can then be, consumed by the network controller to automatically set up the traffic mappings and the policies, right? So it creates an abstraction of the network at the service level in the application service directory. So you have the application developers working in the service directory, which they're fundamentally, as part of their process. And then that creates a clean boundary for NetOps and DevOps to utilize, completely abstracting sort of the network policy details from that application designer, because he's just coded this tag into his service directory that can then be communicated between the management systems, right? So that's how we're basically making this kind of magic happen. In the past, the problem was that, all this information was passed over the wall, right? To the network team. They had to create, a bunch of elaborate DPI matching statements to classify the traffic, and then they could basically create the policy that was needed. Creating these classifications was pretty complex, and it had to be done for every type of application, every time. The policies then, of course, were transferred at the human layer, and that's the difference here, right? We're not doing this sort of application developers talking to network operators now. We're doing this at the machine layer, right? We're communicating these policies that are once agreed upon. So that had in the past made them static and brittle, takes them a lot longer to roll out. And the application policy now instead of being implemented completely by the network team, it's shared. The DevOps team has direct ability to consume those policies without having to go to the NetOps team to basically ask for that. So fundamentally, CN-WAN allows us to bridge that human gap with some API automation.
Tom, you may want to add something.
Yeah, thanks, Marcus. Yeah, so Steve, I think you made some excellent points there. From our viewpoint, it also allows the activation of peering, where it used to be, taken in weeks or months to be able to activate, to be made available very quickly. So activation of peering, being able to deploy network function virtualization, such as routers, firewalls, and SD-WAN edge in minutes becomes critical, enabling dynamic scaling of network connections as needed for brownfield elasticity and greenfield deployments to meet the application workload demand. So previously, as I mentioned, the physical peering connectivity were handled manually using letter of authorizations, which typically takes days, sometimes weeks to get connected, and then being able to then order an appliance which then needs to be rack and stacked at various different locations. Then you need to actually order the connections from your local carriers, which sometimes could take weeks to months to finally get it up and running and working. So with the virtualized functionality and the virtualized ability to be able to spin up using an API becomes imminent in terms of being able to keep up with the cloud capability that we all have come to learn and enjoy.
Yeah, I think that's very clear how important it is. But let us now move on and look into another topic I think is very important to be discussed, right? Because customers also benefit from the broad set of services and capabilities that are provided by the modern applications and network platforms. But there is a challenge, a real challenge. We need to cope with the complexity which inherently is occurring while deploying a large set of features and a huge number of virtual and physical devices. So to overcome that challenge, abstraction of the technical complexity by providing service-oriented definitions to the designers. You may also think even about a service catalog, as well as consequently leveraging central orchestration capabilities and software-defined architectures should be leveraged very consistently. I truly believe that's necessary, right? At Jena, we deliver networking as a service, and we do that by essentially leveraging the power provided by software-defined platforms such as Cisco Viptela. Our platform approaches allows NetOps to access a single dashboard for management and orchestration of network resources and enable things like zero-touch deployments. But how does it really help DevOps? By making networking an abstracted fabric and giving NetOps the ability to orchestrate from a cloud-based platform the networking resources and quality of service needed by applications can be fine-tuned and tailored to the application experience from the start. It's a much bigger degree of customization and flexibility than old models can ever allow or provide. Steve, what does this concept of an abstracted network fabric means for Cisco?
Well, I think it's critical as we go forward, and we certainly do see this change in the way networks are being deployed and how they're being deployed as being a definite discontinuity in the market today. So what we see is more and more need for on-demand services, more and more need for on-demand connectivity, and extracting the fabric with a fabric architecture allows me to basically paint a canvas on top of my network so that I can build my virtual network on top of physical and virtual facilities that are provided by providers like Njena and Equinix. So having that API connection into those into your networks, that we can provision what is needed to create that connectivity in an automated way, does two things. It allows me to abstract the creation, the building of a network. It allows me to have more on-demand setup and teardown of networks to make it more dynamic. And those two things actually enable us to think about now, how do we treat the network as code, the network infrastructure as code, and how can we use DevOps methods now to maintain and expand and contract our network at will. So these are the kinds of things that that we're looking at in terms of how things are put together now with these new API-based methods.
Very, very clear. Tom, I think Equinix has a strong statement here as well, right?
Yeah, thanks, Marcus. Yeah, so certainly from our standpoint, we provide that underlay abstraction, right? Both in the physical sense as well as the virtual sense, so allowing for overlay abstraction to be created. So VXLAN, right? So these are the various different ways that from an Equinix standpoint, we make it very easy, not only for you to actually then manage, but for you to actually build out your network appropriately, as Steve has already mentioned.
Wow. Before we now get to the end of the panel, I think we should spend a few minutes really looking into the future. What do we see the future is holding for SD-WAN, CN-WAN, and whatever may be next in bridging NetOps and DevOps? Tom, what's your view?
I think there's a tremendous opportunity here, Marcus. I think for the new world really to be created. The digital infrastructure is going through a huge transformation. Physically, in the old days, I think we used to rack and stack these appliances. Now, I think being able to accelerate time to market becomes key, and our ability to be able to react to the business need, right? Whether it be in terms of protecting the network, or in terms of being able to scale out and test out brand new markets, those becomes critical to ensure that, from a networking standpoint, we don't hold the business back. So the world of NetOps and DevOps now needs to be able to work with each other to make sure that they can actually satisfy the business needs.
Wow. Steve, your view.
Yeah, so I think it's actually a super exciting time to be in networking these days, for sure, with all the changes that are going on. And here's probably three things that I see the most exciting right now. One is this cloud native SD-WAN integration that we're doing for applications right now. We're talking about user to kind of service, right? But if you think about service meshes and way up distributed applications are built, you could see how this might apply between service components, right? So not only performance, transactional services and things like that that need to have certain performance between application performance could be handled by a system like this, but also security between components and other types of policies, right? So we could see this potentially becoming part of a larger cloud-to-cloud service mesh at some point in the future is a possibility here. The other thing I see as a major trend is that I think is going to be important is the application layer generally communicating performance, load information, other pieces of information to the network so that network can adapt and change what it can control to make the performance of that application work better. Okay, so I see that for sure. So maybe, for example, we can redirect flows from user sites to less loaded service components in other data centers, for example, right? More advanced kinds of load balancing than we've seen in the network, with just ECMP, for example. And then the third area, as I think I touched on in my previous statement, is just as we get more API driven in the network, even deeper programmatic integration of network capabilities with the application CI/CD pipeline, right? And that means more ability to do infrastructure as code and other types of methods that we've seen in the data center, for quite a while now, but doing this in the network.
Absolutely. Now, for me, it's all about helping the customers on their journey towards the cloud, right, into the digitized business processes and the new digitized business world. It's finally all about further simplification of IT environments and increasing the flexibility for the customers. Standardization, the way how different domains can interact with each other without dedicated manual configuration, and leveraging consequently APIs and automation will be absolutely key. Leveraging MEF standards and further developing the capabilities of networking to be a dynamic resource pool that brings together NetOps and DevOps closer together will significantly improve customer experience. And I think we have seen today how these technologies of CN networks, SD-WAN, and bringing together the different domains of Kubernetes and SD-WAN really provides exactly that benefit. Now, being at the end of our panel, I would like once again to thank Steve and Tom for all your contributions and thoughts joining me in this discussion. And of course, especially thank Cisco and Equinix for continuing to be great partners as we work together to develop these new models and solutions for the next generation of networking and really to help our customers move towards this digitized world. Thanks also to MEF and all our virtual attendees who have joined us from around the world. We will now turn over to the question and answer segment, where our collective team will be happy to answer any questions on CN-WAN and take the conversation further. Thank you.
Marcus, Tom, and Steve, great job. They're very comprehensive discussion to show us how this whole thing was pulled together and of course, the opportunities going forward. So now we get to dig deeper by going into our Q&A session. Our moderator today will be Daniel Varlev, MEF's VP of Strategic Programs. He's our moderator for all these live showcases for that matter. In his spare time, he also doubles as our MEF 3.0 POC Program Director. So with that, Daniel, take it away.
Well, thank you, Kevin, and thank you for all the hosting that you're doing for the various POCs. For those that don't know, Kevin Vachon is our COO at MEF, and we're very, very pleased to have him hosting these events. So I'm going to invite the panelists on for the live Q&A. If you could come and join me on screen. And while you're doing that, I'll just say a few words. This is very, very exciting the way that the teams here comprising Cisco and Equinix and Jenna have demonstrated how important it is to bridge that gap between the NetOps and the DevOps community and how to do that. So we've already got questions coming in, and I'll kick off. The first one is, how exactly did MEF help to create this application-aware solution for NetOps and DevOps integration. And I'm going to pass that one to Charles to start with, Charles Eckel at Cisco, because Charles is not only, of course, at Cisco and very involved there, but is also a co-chair of the Digital Services Committee and very familiar with all the SD-WAN work and the LSO work that we're doing. So Charles, I think this is a really, really important question, a very central one. Where does MEF fit in here? What value is it bringing here? And what can we do to bring the two communities together, MEF and CNCF?
Yeah, well, thanks, Daniel. That's a great question. And, I think, so first of all, let me say, I'm a principal engineer at Cisco, and I work in the global technology standards team there. But as Daniel mentioned, I'm also a co-chair of the Digital Services Committee in MEF. So standards are obviously, quite important to me. But I'm also a software developer and a big believer in open source. And so this POC is really a fantastic example of those worlds of standards and open source coming together and really benefiting both communities. So, and it's straightforward to see how the SD-WAN standardization, I think, is really critical to the traditional network service community who's looking for a standard there around SD-WAN, but maybe how that becomes relevant for the Kubernetes community. And so there's multiple ways in which that's happened. And really the MEF standards here just play a critical role. If you look at CN-WAN and what we did with the POC, there's an adapter, right? And what that adapter does is that lets the CN-WAN really work with the Cisco SD-WAN solution. But now, let's say you want to work with another vendor's equipment. Well, as long as it provides support for a MEF SD-WAN service, its inner working should be, relatively straightforward. Now, whenever you have different communities coming together, in this case, the world of standards and open source coming together, it's very important that you have a common language. And the MEF SD-WAN standardization work really provides that for both the standards community, but then for the Kubernetes community, so that when we do come together, the concepts are quite similar and well understood. Now, MEF 70, that is the MEF SD-WAN service standard. And we have been working on MEF 70.1, and that will be coming out soon. And then there'll be a MEF 70.2, because we realized, and MEF realized, that SD-WAN standardization really was needed now, but that SD-WAN standards would need to evolve over time as SD-WAN service also evolves and improves over time. And this iterative approach really works well not only for standards, but especially well in the Kubernetes community and with software in general, right? Where it's much more common to have a release of software, initial release, and then make it better over time. So that works tremendously well. And then also MEF SD-WAN APIs. APIs are a huge part of what MEF does in order to make its work more relevant to developers and to open source communities. Now, those APIs don't actually exist today. Those standards are not complete yet within MEF. But when you look at what the POC has done and the API that's being used there, you can view that as a candidate or an example of what that API would need to look at. And there's a lot we can learn from that. And it points out key requirements of the API so that when we do actually go and work on the standardization, the work that's been done in the Kubernetes community can really inform that work within MEF and lead to a better API, a better standard in less time, and that is embodied in code, the open source code that you've seen today, in a much shorter time frame.
And Charles, would that be in the LSO reference architecture at LSO Legato, LSO Presto, LSO Adagio? Where would that API for the standardized SD-WAN service here in the reference architecture?
Well, you'd see it at both places. You'd see it in those east-west APIs, essentially like a Sonata type of API, but then also going down in the stack, like at the Legato and perhaps even at the Presto level, when we want to actually take the information that has been received from the Kubernetes clusters and program that onto the SD-WAN.
Okay, great. I'm going to move on because we've got a lot of questions and we're a bit tight on time. One question that came in: what would prevent a DevOps engineer from configuring all of the apps they own, in particular as high priority, and essentially classifying them to get the best service? What's the way of managing that situation? Who would like to take that question? Alberto, thank you.
Yeah, Daniel, I can answer to that. This is Alberto Rodriguez Natal. I'm a technical leader at Cisco. That's a question that we get a lot when we talk about Cloud Native SD-WAN, and for a good reason, right? One would think that in the absence of something to stop this from happening, everyone would like their apps to be the best ones on the network, right? So what we need to understand here is that we are trying to coordinate the DevOps and NetOps worlds, right? So the collaboration here comes from the NetOps understanding the network, defining what is possible on the network, and exposing those capabilities to the DevOps, right? So the DevOps know that the network is aware of the application work. And then from the DevOps point of view, trying to specify the best they can the attributes, requirements, needs of the application from the application side of things. But that doesn't mean that the application directly is going to drive the network optimization, right? Because the expertise and the knowledge of the particular network is still on the NetOps side of the house. So the model we are trying to propose here, and we have seen that this is well received by both application and network teams, is that the DevOps specify the metadata about the applications for the NetOps to receive, and then the NetOps define this that map that metadata to network policies, SD-WAN policies in this case, right? But at the end of the day, it's still the role of the NetOps to decide how the metadata from the application is going to map into network policies. So in the example that we saw on the demo, right, what the DevOps is saying is that the application is a video application, and that's it. It's not saying anything about, this should go into the tunnel X or tunnel Y, tunnel gold or bronze in the video, right? And that's the role of the NetOps to say, okay, for the video applications, for applications that the DevOps has tagged as video, I want to put them into this particular tunnel, right, following the example. If the network conditions change, right, if the tunnel performance changes, or if the requirements for that particular enterprise, let's say, for video applications are not that high anymore, that mapping of application metadata to policy may change. And it's still in the NetOps hands to provide that. So we have discussed this with both people in the NetOps arena and also with people very deep into the Cloud Ops, DevOps, Kubernetes community. And everyone seems to agree with that, right? Because that question comes first to mind when we start talking about this. So I hope that answers the question.
So essentially what you're saying is that the applications advertise what would work best for them, but it's really up to the managers of the service to decide how to deal with that. And I assume that the NetOps people are really governed at the end of the day by the policies that are set by the subscriber that's buying the SD-WAN service. So how does that play out? Is the policy involved there, or you see that as a separate issue and what you're doing is solving the problem of the applications advertising themselves in a more automated way in terms of their requirements?
Yeah, so as I was saying, right, the DevOps have little to say in terms of the actual policies on the network. So those are the NetOps based on the, as you said, right, in the subscription that is in place. or the actual condition of the network or the different agreements that may be in place there. But the NetOps has the ultimate word in terms of what happens in the network. So NetOps is network operation, right? So operation of the network, that's the NetOps role. The DevOps may determine what they want for their particular application, but the network is the one that needs to provide that, right? So if the network can provide that in a way that makes sense for the rest of the applications that are running on the network, it will. If not, things need to adapt, right? So you need to find a balance between what you want to do and what you can do.
Well, Daniel, I think I'd like I'd like to add to that if I could, Daniel. Yeah, thank you. I just want to say one thing. So this is a journey, right? We're just starting here. So what Alberto and Fabio and us we put together and Jenna is something, and Equinix as well. It's something together that allows the application to advertise its, as you mentioned, what services it needs. But you can imagine in the future the network will be able to respond back. So right now Alberto's saying yes, there's a people part of that interaction, but in the future, the more dynamic networks, more dynamic services being available in the network, we can imagine the network would respond back, say, look, I can't give you that service class right now. I can give you this service class, and I've mapped you to that. Now the application can respond with a lower rate codec or some other type of encodings, or maybe hold those transactions to a better time. These are the kinds of things we can see happening down the future, but this is only the first step.
Great, thank you, Steve. I'm going to move on. Oh, sorry, go ahead, Marcus. We're going to try to move fast.
Yeah, I just want to add here, I think the interesting piece here is that you just need a one-time alignment, what metadata really tells you, right? If this is understood and therefore standardization plays a significant role, if we have all a common understanding what video traffic means, what later on also, as Steve explained, additional requirements or intents on the security and other areas means, then you can really work very independently, because the right translation of the requirement for a video to a specific environment is something a NetOps has to do, and it can be easily managed via even high degree of automation on the NetOps side. And I think that is the interesting thing. You decouple complexity, and the piece in the middle you need to do is the alignment of how you want to describe the intent. If this is once aligned, you can simply use it without further manual interaction.
Okay, great. Thank you, Marcus. So there are a couple of questions that have come in that I'm going to tie together, and then I'm going to paraphrase a little bit. One of them is what's the typical size and granularity of the CNFs, and where do they live? And the second question that I'm tying to that is, what's the service orchestration platform and assurance platform that you use in this solution? So I think perhaps that question may be for Equinix. Really, how do you manage all the resources in this type of environment when it presumably is very dynamic, as you mentioned in the demo and in the panel, where you're needing to move resources dynamically in order to adjust to the requirements in real time of that application?
Daniel, if I may answer that question. So this is Tom Yin. I head up the business development activity over at Equinix on the networking side. Certainly, I think there's several angles I think that can be looked at. First of all, there is not just one orchestration. I think there are several orchestration engines here that are actually being used. Certainly, if on our side, in terms of the actual underlay, we have our own orchestration engine that we use to be able to provision these virtual network functions, right? And the orchestration of that underlay to be able to also then connect to various different multi-cloud providers or any of the participants on our fabric, right? So that's one layer. Certainly that controls the underlay. We're also enabling device linking, device clustering, as well as the HA capability to be able to allow the overlay to then be able to orchestrate and be able to present that abstraction layer then to the actual DevOps environment, right? So there's multiple orchestration engine here at play. And certainly what we have seen, and maybe Marcus wants to comment on this, is the ability to be able to coordinate the underlay and the overlay together, right? And And in the case of Engina, they've actually provided that overlay orchestration capability.
Great. Marcus, you're on mute.
Thank you for the reminder. So, Tom, there's not much to be added. This is exactly how it works. We really have developed this end-to-end orchestration platform, which allows to more or less deploy and later also to change a global network from an overlay perspective. And in linking up with the Equinix infrastructure, we can also, via the more or less this kind of orchestration from an end-to-end point of view, also automatically deploy the underlay and to provide the needed infrastructures to connect into all the different public cloud environment. That is exactly how it works.
Perfect, thank you. I'm going to squeeze in one last question. We've only got 1 minute left. So the question is, Cisco announced turnkey meshing of SD-WAN into Google Cloud. How might a Cloud Native WAN fit into this future? Just 1 minute, quick answer to that question. Who would like to take that one?
Yeah, I'll take that one, Daniel. Thanks for the question. Yeah, so you're talking about the Cisco Cloud Hub for GCP, or for Google Cloud, which I'll, in a nutshell, it's three things. It's basically a very a close network and resource integration. So a cloud edge that's highly integrated with Google resources and services to make them easier to deploy, much more automated for the customer to get the cloud edge up and running and tie into the Google services. So we're automating right up to the workload level, right up to the backbone level, and just making the customer's job easier to get things up and running in Google Cloud from a SD-WAN perspective. So a lot of cool stuff there. Then there's what we just talked about here, which is I would broadly categorize under the heading of application layer integration. So there's the CN-WAN, which we just talked about, but we're also doing application signature integration as well. So for our software-defined application and visibility control, we can basically pull signatures out of the service directory, use those to identify applications and classify applications at the data plane layer that we can actually apply policy. And then the third layer is a security layer of integration. So of course, we're all very interested in zero trust networking. So far, that's mostly an internet phenomenon, but we're working with Google to basically bring the private network into that architecture in a very meaningful way as well.
Tremendous. Well, it's frustrating because there are a lot more questions I would like to ask, I'm sure the audience as well, but we're going to have to let you go, and I'll thank you and let you sign off from the screen. While you're doing that, I will hand back to Kevin and say that I think there's a lot of importance here, Kevin, in getting the two communities working together, MEF and the Kubernetes community. I think we've got a lot of interesting stuff to do together, so something to look forward to.
Thank you, Daniel. Fascinating discussion. So many different technical components brought together with the NetOps, DevOps integration, MEF standards, end-to-end orchestration, the use of very creative APIs, and I think certainly what stuck with me was the points both Charles and Steve made about the forward-looking opportunities here of functionalities, overlay, underlay, interaction, use cases for future MEF APIs and so on. But I operate at a high level, and so my high level summary of this is that we have essentially cloud native SD-WAN managed services automatically configuring themselves according to the needs of the applications running over them. If I go any deeper than that, I'm going to get in trouble, so I'm going to leave it at that. But it's just amazing how far we've come since we started defining SD-WAN with MEF 70 back in 2017 and talking about 70.1 and 70.2. Great progress. Thank you for everything. If you'd like more information about this POC, you can go to mef.net/POC/136 or just Google MEF POC 136. There's all sorts of information there. POC overview, network diagrams, supporting materials, blogs, and more. And the on-demand, or the POC will be available on demand on that page as well soon. So if you like what you saw today, please have your colleagues visit the page. So as we wrap up today, I'm going to tell you about the MEF 3.0 POC Awards. There are 4 categories. Each POC, of course, is eligible. We have Innovation, Business Impact, Market Game Changer, and Judge's Choice. They are judged by a panel of 8 independent analysts, and we're going to be announcing the winners on March 10th at episode 3 of the MEF Infinite Edge series. So please tune into that. Now, to carry on the conversation with the team here, you have a couple of options. You can see a link here on the screen. There will be an informal meeting after. You can go to that link and you can have Q&A with this team. Or there's also some contact information that you see as well. You can contact them via email afterwards, whatever you prefer. So with all of that, I'd like to say thank you for everybody that worked hard to pull this together, our MEF production team, and of course you for attending. And we'll see you at the next MEF 3.0 Proof of Concept Showcase.